So in this video, we are going to be looking at Rust basics for Soroban smart contract. So in the previous video, I told you that we write Soroban smart contract using Rust, a kind of a dialect of Rust. And in this video, we're going to be looking at how we could get the basics of Rust to start writing Soroban smart contract. This video is actually meant for people who haven't written even a line of Rust before. So to get started, let's kind of first of all see what Soroban is and what Rust is. So Soroban is the Stellar's native smart contract platform, enables developers to build decentralized application. And of course, Rust is the primary language used for Soroban smart contract development. And Rust is actually known for its safety, concurrency, and performance. So Soroban leverages Rust strengths to provide a secure and efficient environment for building smart contract. So we're going to see that. So it has an extensive ecosystem and seamless integration. Rust is actually a very powerful language and a well-suitable language for developing smart contract. So we're going to look at how to set up Rust on our machine. So in order to do that, you need to go to the Rust website. So you need to go to rustlang.org. And depending on the operating system you're using, if you're using Windows, of course, you need to download this executable based on whether you're using a 32-bit or a 2-bit machine. Or for me, I normally like doing my development with Windows subsystem for Linux. So definitely, I just need to copy this and take it to my terminal, and this will get Rust installed. So I just need to paste this link here, and immediately Rust is installed. I've already installed it. So the next thing you need to do, of course, is to check whether Cargo is installed. So now we've gotten the basic setup. We need to start experimenting with Rust. But we will still need to install additional tool chains for Soroban development. If we want to actually, the Stellar CLI, we are going to install that later in the next video where we actually create our very first core Soroban smart contract. In this video, we are going to be looking at, so next, we're going to be looking at cargo basics in Soroban. Welcome to this section. In this section, we're going to be looking at cargo basics in Soroban. We are going to be looking at the cargo CLI commands. So let's go to our IDE and see how it works. So I'm using Visual Studio Code for this. So we have to make sure that we have the Rust Analyzer add-on here. So Rust Analyzer, make sure that you install it. So make sure that it's installed. It definitely make your life a little more easier. So the next thing you need to do is to use the first command we're going to be introducing today, which is the cargo new. So cargo new, and then the name of your project. For example, I'm going to be calling this one Soro Rust. And then this is going to create our project. When it creates this project, it's going to give us a cargo.toml file. So what you see in this cargo.toml file is basically your package. So this is the name of your package, the version and the edition. And this is where, for example, you could add dependencies. For example, I could come here and ask the Soroban SDK. And because of the add-on we added, for example, it's telling me here that this one is actually an old version and the most current version available here is 21.7.2. So I could choose this version, for example, and you see everything seems fine. So I'm going to take it out because I don't want the build process to take a lot of time. So now we have our project already. So we have the main file here. So we just have a basic file here. So the next thing we need to do is try to kind of build this project. So the command that Cargo uses to build your project into a target is called cargo build. So you're going to do cargo build. And then when we execute this, so the error is because we've not changed to the proper directory. So we need to do cd soro rust. And now we need to type the command cargo build. So this is going to build our project. So the reason why there was a little delay, it was because the Rust Analyzer is also running a command called cargo check. So it uses that command to check that everything is fine in your project. So now what we're going to do next is, so we've used cargo build. So when we do cargo build, what happens is that it builds an executable into our debug folder. So you have here in the debug, you see here, we have sarorust.exe. So because I'm actually on Windows. So the next command we want to do is the cargo check. So if you're writing your program, for example, and you made some mistakes that will make your program not to be. So cargo check is more like building your project but without producing the executable. So you see cargo check. So it's going to check that everything is fine. So you use this one if you want to find out that your project is good and nice. So the next command I will be introducing is the cargo run. So cargo run is similar to the cargo build. It's going to build your project but also execute it. So you see here, it builds it and also executes the Hello World program. So the last cargo command I'm going to be showing you is now we are building basically for debug. So if you want to build for release, so you could also use the cargo build and then you're going to do dash dash then release. This is going to produce the release of your build. So you see here, we don't just have in the target folder, we have debug, but we also have the release. So the release here and the debug. So the next thing we are going to be introducing is to look at how we can work with ROS models in our contract. So in this section, we'll be looking at how to organize our code. So I'm going to be switching to the IDE to show you how we could organize our code using models. So let's assume we want to define some piece of functionality. Let's say we want to define some functions in a file here called funcs. So let's say we want to call it funcs.rs. So how do we now include this func.rs into our main program here? So we do that using what they call models. So we could define it as a model here by saying mod funcs. See? So that means we've added it. So whatever we define here, so if you come here, for example, and define a function that adds two numbers. So let's say, for example, we say func add, and then we decide to say, okay, it takes this and returns this. So you see, so basically here, we could use this very function in our main program. So let's see it here. So we could say, for example, we could say let x be equals to, so you see, so this is how we can call that function. So let's see here. So you see here, the problem here is that so in this section, we're going to be talking about how to organize our code in Rust. We are going to be organizing our code using models. So let's switch to our IDE and see how that works. So here we have an already existing Rust project. So what we need to do is create a model. So to create a model, we just need to, for example, define our functions here. So funcs.rs. And then this is a model, but we need to add it here to our main. So the way you add a model to your main tree, your main program, is by doing mod and then providing the name of the file, so funcs. And this is how you define a model. So a model has been defined. Now we can go expose a function inside of this model. So for example, I could define a function here that adds, so let me just say pop, and then I could say func. And this function is going to add 2i32, you see, and then here it returns the result here. So we necessarily do not need to put a semicolon at the end here. So all we need to do to use this function here is so we could define another variable here. So we could say let result. So you could see here equals to this, and then we could just print the result. So we'll just take this one out here. And the way we do that here is we could do this. So And then this is similar to using dot format. So it's formatting the result here, putting the result here. So when we execute this, you see we get the result as 3 because we are adding 1 and 2. So the same thing you're still going to do if you're writing test. So you're just going to define a module here. So you're going to define a module here, and then maybe you call it like test or your tests. And then you just need to define a file here with the same name with tests.rs. You see, and then you could write your test in this file. So you could write, for example, I think you could define some configuration here. So I think that's what they do. And here you put test. So this is only going to run. So when you do this configuration test, this means that when you execute this program, the test is not going to run. It's only going to run when you want to run, when you do cargo test. So that's one of the commands that I didn't show you earlier. So when you do cargo test, that is when the test is expected to run. So let's continue to write test for our program. So the way we do that is by, so we need to put like, I think I forgot to put an exclamation here. For now, until we talk about macro, this should be okay. So this is just saying ignore when we do a cargo test, then it's going to run only the files in this test folder. So now you need to kind of like start creating the test functions. For example, all you need to do is just annotate it with this test. For example, test add, and you see what's happening here. So the reason why this one is not declared here. So if you want to make it here, we could do something like this. We could do use let's say super. So the use statement, so we could do something like use super, and this works. So this means it should, super means it should use the functions that are within this project. So you could just use superstar. So you could definitely go and use all the models that we have here. So including this. So now you see how we can write tests. So when we are building our tests, you see our tests were able to pass. So when we are writing our tests, we will also use this even in our Soroban program. We'll also be able to add this model. So it doesn't actually matter where you put it within the tree. So we could just take it towards the end here and make sure that it doesn't conflict with the other piece of code. And you see here, it's indirectly saying I should run tests. So when I run tests, only the test runs. So, and also when I decide to run the entire program, you see, it's going to omit the test. It's not going to run tests. It has produced our executable here, and it's produced our result. So this is all about organizing your program. I know there are more advanced topics in this section. I want to make this as brief as possible so that we could look at a collection of topics that can get you started with writing smart contracts.